So XAI just open sourced the X recommendation algorithm, and they massacred my boy. Scrolling down, I expected to see language stats like that of the 2023 repo. But no, they were gone. The only languages listed, Rust and Python. So this wasn't just a simple refactor of the algorithm, it was a complete rewrite. One that had me thinking, wait a second, I thought Rust was supposed to replace C and C++, not Java and Scala. So I wanted to take a closer look and figure out why replace Java with Rust. And luckily for me, we have access to both code bases, so we can take a look at exactly what they replaced. Like Twitter's custom Scala framework, Product Mixer, which they use to build services like Home Mixer, what serves the For You recommendation feed, and systems that produced hand-engineered systems like Sim Clusters, TweetCred, RealGraph, Early Bird, and dozens more interconnected microservices that made up this algorithm. So the engineers would literally sit down and say, let's add a feature for whether the author of a post replied to the comments and weight it at 75. That's hand engineering. Yeah, that all got completely ripped out of the codebase. No more hand-engineered features, or in other words, no more Java and Scala, because these are the languages that were used to build those. So those dozens of interconnected microservices went away, and after it was all rewritten, which we'll dive into, we were left with this. 4 directories, 4 components. That is the entire algorithm. Kinda. We'll get into that rewrite here in just a second. But we need some context first. You see, Home Mixer, which was our last little bit of Scala and Java left, was entirely rewritten in Rust. It still serves the For You feed, but with a completely different approach that I'll explain. Thunder, also written in Rust, is an in-memory post store. Candidate Pipeline, Rust again, is just a generic framework for building recommendation pipelines. Here's what those pipeline traits look like. And Phoenix, written in Python, which is the heart of it all. It has retrieval for out of network, but also a grok-based transformer, which does the actual ranking of your posts and what you should and shouldn't see based on your interactions and your behavior. That's the new system, but in the old system, pipeline components were in Scala classes, extending product mixer traits. Here's one of their scorers. It's Scala's scorer trait. Now here's the Rust equivalent. It's the same pattern, trait-based pipeline composition, but Rust gives you, as much as I hate to admit it, quite a few perks, like async native code, explicit thread safety with send and sync bounds, and 0 garbage collection overhead. Not only that, but with Rust, as we know, the compiler enforces correctness, whereas with Scala, a lot of it is left to runtime. The old algorithm also had explicit hand-tuned weights. So like how I said you replied to comments plus 75. Or if you report a post, minus 369. All of these numbers were handpicked by humans, presumably throughout numerous meetings, with lively debates and fine-tuned over the years. And most of these heuristics, just like the hand-engineered features, ripped right out of the codebase. Because Phoenix, the grok's transformer, doesn't need them, at least how they were. It learns engagement patterns directly from your behavior. Which is why when you click on a single political post, your entire feed is just filled with politics, hoping you get caught up in it and stay on the platform forever, arguing with what are probably foreign-run bots. Now back to Home Mixer real quick. In the old algorithm, Home Mixer orchestrated the dozens of services, calling Sim Clusters for community data, TweetCred for reputation scores, RealGraph for relationship strength, then combining all of those signals with the hand-tuned weights. That was the algorithm. Now Home Mixer just fetches candidates from Thunder in network and Phoenix retrieval out of network, then feeds it to the grok transformer in Phoenix to score. It all got simpler, the codebase shrank because the intelligence moved into the model. But there is an issue with this codebase, and that is, well, it's not reproducible for us. We have no model weights, there are no cargo.toml files, so we can't even compile it if we wanted to. The proto definitions are external, and all of that logic from the old algorithm is now inside the model, which we can't see. We went from a 48 million parameter mask net running inference to a grok transformer that absorbed what all of those microservices used to do, which I think is a clear reason why XAI replaced Java and Scala with Rust and Python. Now, there's no official engineering blog yet, but we can connect the dots. It's not that all of these microservices in the codebase was rewritten in Rust and Python, but that it was all absorbed by the model. And they wrote the Rust and Python code to really just connect and orchestrate everything. And for good reason, I think. Thunder, the in-memory post store, well, it needs sub-millisecond latency for real-time serving. And on the JVM, garbage collection pauses are unpredictable. It's the JVM's kryptonite, at least in my experience. It's always been my biggest complaint about it. And while you'd be fine 99% of the time, you'll randomly get a 200 millisecond pause right when you're serving a feed request, which I would say is unacceptable. And that's why X decided to use Rust. But this seems to happen more on X than ever before. So I don't know if they're just vibe coding their Rust code or what they're doing over there, because it ain't working right. And also, all of Elon's companies use Rust in one way or another, from Tesla and SpaceX, and it seems that XAI was built from day one with this exact stack in mind. We are looking at a genuine architectural shift in the industry. Discord rewriting a lot of Go in Rust, Cloudflare building a whole Nginx replacement in Rust, Linux accepting Rust into the kernel, and now this. A decade of Scala microservices being replaced by 4 Rust components, well, one is technically Python, and a transformer that learned to do what 1,000 lines of hand-tuned code used to do. The question isn't even whether Rust is replacing Java or Scala. It's whether AI is. AI is replacing algorithms that used to be this vast code base. And Rust, well, it just happens to be the language that people reach for to glue all of the pieces together. And if you want to do that, you need to understand how these systems actually work. That's why I've been using Brilliant, because their How AI Works course actually walks you through transformer architecture and attention mechanisms, the stuff powering the systems like Phoenix and Grok. But what's nice about it is that you're not watching lectures. You're solving problems until the concepts actually click. Because if you've ever thought, I'm not a math person, it is likely due to how you were taught, not because you're not a math person. And Brilliant accounts for this in all of their programs, from math and physics to computer science and programming, by personalizing everything. They start you at the right level and they keep pushing you forward as you get better. It's also a very good way to just kill some downtime, because you're able to do a lot of these problems on your phone. So if you're sitting there waiting for your doctor or waiting for whatever, you can just knock out a couple of these instead of scrolling. Do something that actually helps you. So if you want to actually understand what's happening when a model learns engagement patterns, instead of relying on hand-tuned weights, go to brilliant.org/forestnight, free for 30 days, and my viewers get 20% off annual. Just click the link in the description. If you want me to go deeper on any of this, the Grok architecture, the pipeline patterns, or how this compares to Meta or TikTok, just let me know in the comments.